Hi, we're continuing on with topic 2 of our chemistry unit. And this is part is looking at redox reactions, which we'll explain in a second. So here it says gain and lose or loss of electrons. It says single replacement reactions between an ionic compound and another metal involve the transfer of electrons from one substance to another to form a new compound. So in this reaction above, oxygen in Fe2O3 reacts with solid aluminum to form aluminum oxide and pure iron. During this process, aluminum loses electrons and iron gains. And how does that work? Well, let me show you what that exactly means. So when we're looking at if things gain or lose electrons, we need to look at, charges of these things. Okay. So we need to look at the specific metals, because we know that metals are the ones that have charges. Non-metals, okay, they have charges too. But we need to look at each individual, normally metal. So this is iron, and we're going to look at iron from one side to the other, okay? We're going to also look at oxygen from one side to the other. And we're going to look at aluminum from one side to the other, okay? So we've got to look at those three different elements. Okay, so if we look at iron, I guess what we have to do is figure out what the charges of iron on the left-hand side. And to figure that out, you guys normally know that we look in the periodic table to figure out what the charge of things are. But iron is an transition metal, so we need to be able to sort of go backwards on that. So let's do oxygen first. So oxygen, we always know, has a -2 charge. Okay? So in this compound, FeO, it has -2 charge. If we go over to the other side, put my hand in the wrong spot. If we go to the other side over here, it also is going to be a -2, because oxygen is always just -2, okay? Okay, let's go back to the iron here. So now that we know that oxygen is -2, we have to do a little bit of detective work, and this is something we did in Science 10, if you remember. So if we split this element into its sides, the oxygen is -2, and we've got 3 of them. So 2 times 3 gives us -6. So that means that this whole side has to be +6 to be balanced, because our compounds are always balanced. They're always sort of the same charge. So to figure this out, we need to figure out, okay, if this whole iron side is +6, there's 2 irons. How much is each iron's charge? So we go 2 times what gives us 6? And the answer would be 3. Okay. And maybe that's more than we actually need to do, but I'm showing you that so you know where I'm getting this from. So if iron is a +3, we need to figure out what it is on the right-hand side. And this is sort of an information for you guys to know, is that the charge of something, a solid element by itself, it has no charge, okay? So it's just a solid piece of iron, it has no charge. So whenever you see an metal by itself, it doesn't have a charge, so it's going to be 0, okay? And then the last one here, aluminum, we've got to look at it from one side to the other. So like I just said, aluminum is by itself here. So a metal by itself, it's 0. Okay. But when it goes into a compound on the other side, it does have a charge. So if we look at the periodic table, we can find out that aluminum has a charge of +3. Okay. So now that we know this, we can analyze each of these little reactions. And basically what we're doing is we're just analyzing the lines that I gave. Okay, so let's look at iron from one side to the other. So from iron, it goes from +3 to 0, okay? And I think I might be, yeah, it says it right here, but I'm gonna write this here. So we got Fe +3, and it goes to be Fe just by itself, okay? The second one, oh my gosh. Is aluminum, and it goes to be aluminum +3. Right, and the third one is oxygen -2, and it goes to be oxygen -2. All right, so I'm just writing down sort of what happens here from one side to the other. All right, so if we look at these, they're these separate reactions. They all have something different about them. So if we look at this first one, iron goes from +3 to 0. Okay, so this is a 0 charge. So when we go from +3 to 0, we have to figure out, is that losing electrons or gaining electrons? And we need to remember that electrons are negative, okay? So when electrons are negative, something that's becoming more negative is gaining electrons. And something that's becoming more positive is losing electrons. So in this case, we're going from +3 to 0. And remember, if we think about, like, I'm just going to do, let's say this is 0, 1, 2, 3, a number line. If we go on a number line from +3, which is right here, and we go this way to get to 0, we are becoming more negative. We're going in the negative direction. So something that's becoming more negative is gaining electrons. Okay. So iron in this case, from this side of the reaction goes, +3 all the way to 0. In doing that, it's gaining electrons. So there's only ever going to be one thing that gains electrons, so automatically the other thing is going to be losing, and then the other thing in the reaction is going to be staying the same. And we can look at this already and see that oxygen stays at -2, so it's staying same. And our aluminum is going from 0 to +3, so that's becoming more positive. So when you become more positive, you lose electrons, okay? So that's all you really have to do in these questions. That is, well, it looks like a lot, actually. I guess it just looks like a mess. But basically, you're going to look at each of the elements, figure out what is happening to their charge, and then you can decide which one's losing, gaining, and staying the same, okay? So it says the process of losing electrons is referred to as oxidation. So the one that loses electrons is oxidizing. So in this case, that would be aluminum, right? And Oh, it tells you right here. In this reaction, aluminum is being oxidized. So the process of gaining electrons is referred to as reduction. And in this reaction below or above, iron is being reduced. Okay? So that's the one that gains electrons. It says, thus, this chemical reaction involves the gain and loss of electrons, is referred to as a redox reaction. Okay? These are called redox reactions because something gains and something loses. And if we break down the words redox, if I can. So that's reduction, which is re, and then the ox is oxidation. Okay, so that redox reaction is literally just, we've got something that's being reduced and oxidized in it. And it's showing you in a more simple way right here. Yeah, the iron it gains 3 electrons from one side to the other, and aluminum loses 3. Okay. Why is this important to us? It's basically, this is how batteries work. So we gain and lose electrons from one side of the reaction to the other. And that's basically electricity. That's how electricity travels. So it's moving electrons from one side to the other. Okay, so these are actually really important reactions in our daily life, and this happens in a battery, which we'll talk about in a little bit. I'll probably leave that until tomorrow, but I'm just going to do this little section for now. So something to remember or something, this is what they always say in this. Everywhere I've learned since I was a teacher, they always say Leo the lion says grr. To me, that is sort of confusing, but what it says is Leo, so loses electrons oxidized. The lion says grr. Grr is gains electrons is reduced. I'm going to give you an easier one. This is what my teacher told me when I was in school. So my teacher told me oil rig. This is just like a mnemonic to be able to remember how, if oxidation and reduction is losing or gaining. So oil rig, oil is oxidizing is losing. Rig, reduction is gaining. Okay, so to me, I don't know, this is probably just because this is what I learned. This is what I remember, but oil rig, if I remember the word oil rig, oxidizing is losing electrons, and reduction is gaining electrons. So that's talking about electrons. Okay, so when we figure out which one is which, like which one's losing, which one's gaining, then all we have to do is put these labels on it. So we say this one's being oxidized and this one's being reduced. Okay. So it says redox half reactions. Any chemical reaction involving the gain and loss of electrons can be broken down and written as 2 half reactions. The oxidization half reaction describes the element that is losing electrons. Thus, electrons are always written as a product. The reduction half reaction describes the element that is gaining electrons, and thus electrons are always written as a reactant. Okay, so we'll show you that as an example. So from this example that we just did, if we look at iron from one side to the other, it was gaining electrons. So we're gaining them from one side to the other, so we put them on the reactant side of the reaction, if that makes sense. So This is on the reactant side. So when you're gaining something, you put it on the reactant side. Remember, reactants are on the left. If I can write here. And products are on the left, or on the right. So then aluminum is losing electrons. So when we're losing something, it's always going to be on the right side of the reaction. We're giving it off. We're getting rid of it in the products. And then our oxygen doesn't change charges. So that is just left there. Okay. So what is oxygen? Well, it's called a spectator ion. So ions that do not gain or lose electrons in a reaction are referred to as spectator ions. So oxygen didn't change from one side to the other. So it's just spectating. It's just watching. It's not involved in anything. It's just chilling there. Okay. That's what, so that's that third thing. So we got reduction, oxidation, and then the spectator. Okay, so here it wants us to determine whether each of the following half reactions represent oxidation, reduction, or spectator. So we can do some of these as an example. So let's do number 1. We got chloride and 2E. So determine whether each is represent oxidation, reduction, or spectator. Okay, so this one we probably don't even need to write anything down, but I'll write it out here anyway. So all we're deciding is it's a gaining or losing electron. So we could, because we just did an example there that showed us sort of like we can see where the electrons are, but let's look at this. So from this side, this is just chloride by itself. That's going to be 0. On this side, it has a -1. So from the left side to the right side, it is getting more negative, right? So when it gets more negative, that's gaining electrons. Why it says 2 electrons is because there's 2 chlorides. So really, I was just looking at 1, but it really doesn't matter. So we're just gaining electrons, whether it's 1 or 2, it doesn't matter, we're still gaining. And gaining electrons, if we look back to my little mnemonic, which is oil rig, we're gaining electrons, so gaining is redox, or reduction, sorry. Okay, so back here it says determine whether these are oxidation, reduction, or spectator. This one would have to be a reduction, okay, because it's gaining electrons. If we look back, see how we got electrons on this side and it's gaining. So we can always just tell that if we have electrons on the left-hand side, it's gaining, but I wanted to show you sort of another way or how we would actually figure that out instead of just memorizing some trick. Let's try number 2.